Hi Circuit Kids, today we're going to be making this bedside clock, desktop clock. It's a clock that can really be put anywhere, but it's all done by soldering a whole bunch of components to one of our CircuitKids circuit boards. Alright, let's get making. Alright, so let's have a look at what's in our CircuitKids clock kit. Open it up. See lots of different components in here. First of all, we've got our CircuitKids printed circuit board, our PCB, with all the through holes and connector pads that we're going to be soldering to in a moment. And we have a couple of pieces of perspex or acrylic plastic that'll become the front and back of our clock. And then a range of other electronics and mechanical components in here that will put together a little bedside clock with a LED display. So I'm just going to spend a couple of seconds organizing all of this stuff so that we can get started. Okay, so we've got our PCB and the covers. Now these are the electrical components and a few mechanical components here. Let's have a look at the mechanical ones first. There's just a few bolts and nuts, and these are little spacer cylinders that will keep the outside casing away from the circuit board. So that'll be one of the last things that we do. With electrical components, we've got quite a few things. We've got the battery terminal, and that will connect to a 9-volt battery. We've got 2 LEDs, 2 momentary switches. We've got a little voltage regulator which helps to keep the power running smoothly around the circuit at the consistent rate. This little unit here is a crystal oscillator, and it's a little device that helps keep time, and we need that because our clock needs to keep good time. We've got 4 LED panels here, which are the digits that the clock will read with, and you just need to look out for these on the back. There's some pins which are very easily bent, and we need those to be quite straight to get them into the circuit board accurately, so just be careful of those. They also have a little bit of protective plastic on the top which you might want to peel off at the end. This is a chip holder or a holster, and it will hold the brains of our clock, which I'll show you in a minute. So that will get soldered down to the circuit board. Then we've got some capacitors, 2 different sizes, 2 smaller ones and a larger one. And the capacitors just store energy, and that helps to keep everything running smoothly with our current. Then we've got some resistors which will bring our voltage down to match the voltage of all of these LEDs that are running here. Now the thing I want to point out is there's 5 resistors that are at one particular resistance, and then there's one that's at a different resistance. So what you've got to look for is the coloring, the colored bands on the resistors themselves. So you can see this one here has these red bands on there, and on this one, if I put it side by side, you can see that they are different colors. So the one with the brighter, almost orange bands, they're 330 ohms, and this one is 10,000 ohms. So make sure you identify those before you start soldering. All right, that's all the components. Let's get making. All right, you're also going to need your soldering iron, which I've already turned on and it's heating, some solder wire, and you'll need some pliers as well. So I'm going to choose carefully which things I solder in first, because if I solder in really difficult things that are in the middle here last, I'm going to have less room to get in there. So In this particular project, it's probably better to start in the middle and then work our way to the outside. I am going to leave this main chip right towards the end. Probably this will be the last things, but then I'll have done this already because that's got quite a few solders in it, and by the time I've done all of this, I've probably got the hang of it and I'm feeling a little bit more confident. So I'm going to work my way along here. I'm going to do these ones down here, then I'm going to do the 7 segment displays up here, and then I'll do the chip and these last ones here that are in my way. So let's get started with this row here, which is resistors and a switch. So all of these resistors here are the same ones, 1, 2, 3, 4, 5, and that's these 5 330 ohm ones here. The 10,000 ohm one will go here at R1. So we're going to do R2, R3, R4, R5 and R6, and we're going to put those in a row, and then we'll do the 2 switches. Let's get to it. Now I'm going to use a tool that's very handy for soldering projects on your own, and it's called a third hand. Now there's lots of different types, but this one basically has these arms with a little alligator clip on the end, and it's quite heavy at the bottom and it just holds things in place. So the one I've got here has a little flexible arm, and this one is a solid arm. But when I put it in the alligator clips carefully on the corners here, it will hold that for me, and I don't have to hold it with my hand. I can use both my hands for working with the project, and that's why it's called a third hand. Okay, so in here I'm going to solder my first of these 5 resistors. So I'm just going to get those and put them right next to where I'm working so they're ready to go. Now what I like to do is take the resistor and fold it pre-folded so that it is ready to go through the circuit board. So I'm just going to pre-fold my 5 resistors here. Okay, so if you wanted to, in fact I'm going to, you could put all of your 5 resistors in the circuit board and then flip it over and solder all of them. So for this part we don't actually need it to be held, we're just going to hold it in our hand. So these resistors have no specific polarity, so they can go either way, it doesn't matter. But if you're a bit picky like me, you might want to put them all in the same way so they look the same. So I'm going to put mine with those reddish color bands at the bottom, but all I'm doing is just poking each of the prongs through the holes, and the resistor itself will sit on the rectangle on the printed circuit board. Okay, so I have my resistors sitting on the circuit board now, but they've got to get soldered, and the trick is when I flip it over they're all going to want to fall out. So if that happens, that's okay, just put them back in again. But what I'm going to do is I'm just going to try and keep my fingers on it, or you could even grab something flat like a piece of paper or even the clear cover and pop that on there, then flip it and then slide that piece of paper or the clear case out from underneath so it doesn't get hot, and then you should see all of your prongs sticking up. If you just give them a bit of a straighten so they're not in each other's way, and it's really good practice just to get prepared before you start soldering. Okay, so soldering these 1, 2, 3, 4, 5 is 10 little solders through those through holes. So I've got my soldering iron all heated up now, and it's just a case of applying a little bit of heat to the through hole and to the resistor prong, and then touching on a little bit of solder and basically trying to get that little hole filled up. So I'm going to go ahead and solder on all of my resistors. Okay, so it looks like I've got those soldered on. When I look on the other side, I've got a little mound of solder in there, but no big ball of solder poking through, which is a really good sign that that's a better solder. If you've got too much solder coming through, that's usually just too much solder, so just back off a bit on the solder. If you're not feeling that confident with your soldering, make sure you go back and check the soldering video so that you can practice that on something else before you use it on your good project here. So there's my 5 resistors. I'm now going to put these 2 switches on. Now you'll notice that these switches have little rectangular pads there, and I'm going to place some solder on those and then place the switch down on it and apply the heat again to melt it onto the circuit. So I'm going to pop this down. Now I do have these prongs now that are sticking out the back. So when you go to put that down, it's going to sit kind of a bit weird. So I actually am going to trim those off. So that's just an easy case of just turning it over, getting some pliers, and then close as you can to the board, just trimming off those little prongs. And just make sure you get rid of those so they don't get stuck in anything. Okay, so that's a lot neater now, and I can put that down here. Sits a bit better. Now it is a little bit wobbly here, so I am going to use my third hand. And I'm going to apply my solder to the top of these pads for the switches. So this is SW1 and SW2. Okay, so hopefully you've done that reasonably neatly. Now it's time to put the switches on. Okay, so here's my 2 switches. These are momentary switches, so when you press them on, they stay on. When you let go, they release. So they will have these little feet on them, and if you sit them on the circuit and they're sitting a little bit too long, then just use your pliers to just trim those off and bend them whichever way you need to, so they sit nicely on your circuit. So for this, I'm going to sit it exactly on top of my pre-soldered pads, and I'm just going to apply a little bit of heat to the top of the foot, of each foot, and that should transfer into the solder and melt it through. So by doing that, I'm transferring the heat directly into the solder. Let that cool. Do the other side. And if you feel like it needs a little bit more solder on, then you can. Alright, so as you're going, have a really good look at your solders and make sure that you're happy with them. Sometimes just applying a little bit more heat will see the solder kind of spread out a bit more and get a better contact. But when you're happy with the first one, go on and do the second one. Okay, the next piece we're going to do is this voltage regulator. Now the only thing about the voltage regulator is if we put it in like this, it's going to stick up too tall and the case won't be able to go on later. So we actually need to bend it back, and because of that we don't want to put it all the way down. So when you push it down, you'll notice that it will go all the way down. See, there's a little section there where the prongs get thicker or wider. So we only really want to go down that far, and then we'll bend it over, like that. So if we've bent it over like that, then that should be about the right position. So I'm going to flip it over, and we're going to have to solder these 3 prongs onto the circuit board. Same deal again though, it's just a case of being really careful with where you put the tip of the soldering iron. That's why I like this conical shaped one, very fine point tip, because I want to make sure that I don't get any solder between these 3 prongs. If I get any between there, between these 3 connections, it will join those and that will cause a short. Also, something to note, you can see on the diagram that there's a thicker line at the top and a single line at the bottom. The thicker line represents this metal part that's on here, so make sure you line that up correctly. Otherwise you'll be putting it in back to front, so just double check that before you solder it. Once you've got it in there and you're happy. Okay, so I'm going to be really careful with these ones, not too much solder. Alright, and I'm having a good look at those before I go any further. If I feel like there's anything touching, I might need to fix that up, but at the moment they look pretty good. What I'm looking for here is, if I'm running my finger underneath, I'm looking to see if I can see my finger through any 3 of those holes, because that means I haven't got enough solder in there. But that looks pretty good. So if there's not enough solder, you can easily just add a little bit more. If you've done too much solder and you've got a bridge between any of those terminals, that's a bit of a problem. So you're going to have to be really careful and try and put a bit of heat in there and pull the solder across. Or you can sometimes buy a solder desoldering tool which kind of sucks up the solder. That might be useful too. So you're much better off doing a little bit of solder at a time and then adding more if you need it, not too much solder. All right, now that I've got those 3 in, I'm going to trim off those 3 prongs. All right, we're looking neat. Now I'm going to go down to these components here, just these 2. So one of these is a capacitor, C1, and the other is the power. So I'm going to do the capacitor first, C1. That's the larger of the 3 capacitors. So we've got this larger one here. Now these capacitors also do not have polarity, so we can put them in either way. Some capacitors do have a specific polarity, but these little ceramic ones don't. Okay, so once you're happy with that, sitting in there like that, same deal as before, flip it over and apply a little bit of solder to each one. And I'm always inspecting as I go that I'm happy with it, and then I can trim off those 2 prongs. 1, 2. All right, we're getting there. If you find that that capacitor is in the way, you can also fold that over when we put the front and back cases on. All right, now the 9-volt power. So this is the connector that goes on the top of your 9-volt battery, and these wires come through onto the circuit board. Got black for negative and red for positive. So we're going to treat these just the same way we've treated all the other components, except for the fact that I'm going to put these wires from the back up and through the front of the circuit board, only because I want the battery to run out the back of the clock. So just pay attention that we've got a plus here, which is the positive. So I want my red one on the left side, and my black one is on the right side. So just take your time to line those up in through the holes. And this is where my third hand might come in really handy. Okay, so I'm actually using one hand to position the wires in the right place, but I'm actually going to hold the wires with my other third hand, and then I'm going to get everything in position first before I go anywhere near the soldering. So this is a bit tricky, so you're going to have to take your time with this one. If you've got someone to help you, of course, that's a lot easier. Okay, so I've got those tiny little exposed wires from the 9 volt. I've got them sitting just above the circuit board surface, and now I can put my solder on there. Just being really gentle not to push those wires through. And if I'm happy with that, hopefully that's soldered in quite well. Yep, that feels good. So again, I'm looking to see, is there any bridging across here, any shorting out? Looks pretty good. And we're starting to get there now. All right, so my power doesn't really need trimming because they were only really short anyway. Double checking, I've got the red going to the positive and the black to the other one, and this will run out the back to my battery. Okay, I might do these 7-segment display modules now. There's 4 of those, and I've got 2 LEDs. Actually might do those first because they're in the middle. All right, so I've got these 2 LEDs which are going to flash while the clock is running to show the seconds counting. Now on the LEDs we've got a positive and a negative. The anode is the positive, it's the longer one, and the cathode is the negative, it's the shorter one. You'll notice on the markings on the circuit board there's a plus sign. So it's important that the longer anode goes through that hole with the positive. So I can push that one in. Same with the other one, I'm looking for the longer one, and that's going through the positive. Lining those up carefully. All right, so they're going to sit there. Once again, I flip it over, and that's 4 more solders I need to do. So I'm going to do those right now. Checking. Looks good. I can easily straighten these up on the front. Just give them a little push. And trim off the prongs on the back. Nice. Okay, now moving on to the 7-segment display units. Okay, now I know these are hard because I've done these before and you want everything to be pretty still. So on these 4 units, they're all exactly the same, but you'll notice these little pins. And if any of those pins are bent, this is going to be a fair bit harder. So just be really careful that you don't bend any of those pins. So you look on the printed circuit board and you'll notice there's a dot in the bottom right corner of the display. So you just match that up with the dot that's in the bottom right corner of the unit, and that should be the right way up. So I'm just taking my time, trying to really carefully align all of the through holes with all the pins. And I wouldn't try and do all 4 at the same time. I would do just 1 unit, and then once you've got that lined up, then you can solder it and it will be nice and steadily in there. Now I've got one end in, but the other end is a little bit more difficult. So I'm just carefully looking at that. And if you need to, you could use your pliers or even a little bit of one of the prongs that you've cut off just to lever any of your pins that are maybe out of alignment across a little bit so you can get it. It's quite difficult. So I'm very, very close to getting that in there, but it's just proving to be out of alignment by a tiny millimeter. There we go. So you've just got to be patient and push that all the way in. Once that's all the way in, you'll see the prongs sticking out, and that's the hard part done. So I am just going to do one at a time, but I'll go through and I'll solder all 4 of these, but just do one at a time. Okay, so one thing you're looking for when you've got a decent solder is you want the solder wire where it's melted on to kind of make a cone shape going up onto the prong that you've just soldered. If you've done that, you've done a pretty good solder. So it takes a little bit of time, a little bit of practice to get that right. Again, I'm just having a look at it just to make sure it's good. And when you're happy with it, go ahead and do the next one. Okay, so I've got my 4 LED displays in here. I've only got a few things left, and that's a resistor, my crystal oscillator, 2 capacitors, and then the holder for the main chip. So we might do the chip next, and that's the most difficult part of the whole project. Not because the soldering is different, I guess it's just because there's a little bit more pressure to get it right. Now the chip is the most important part of the whole project because this chip holds the code that runs the clock. If we don't get this right, nothing will operate correctly. So we really do need to take our time with this one. So the chip will go in this holder, and that just allows you to take out the chip and put it back in again. If you ever needed to take the chip out and repair it or change the code, you can disconnect it from the holder rather than trying to unsolder it from the board. So we're going to line up all of the holes, same as we've done with everything else, so that they fit through the circuit board nicely, and you'll see all the prongs coming out the other side. So I'm just running my finger across there just to feel that there is a prong coming out of every single hole. Make sure that that's flat. Now there's something really important that you need to look out for. On the outline of the chip on the circuit board, you'll notice this little notch on one end, and that matches the notch that is on the end of both the chip and the chip holder. So there's no notch at one end and a little semicircle notch at that end. So you've got to make sure you get that round the right way. And even if you get that right, if you don't put the chip in the right way, with this little notch that's out of the end of it here, has to be in the same end. So just take your time to get that right. Otherwise, it's the same thing. You flip it over, you get it settled and seated the right way you want it to, and then you solder it all together. Okay, so hopefully you're getting more confident with your soldering. I feel like I did a pretty good job there. And you won't need to trim any of these off because they're already fairly short. So if you've got that soldered in correctly, then we can move on and do the last row of things, and then we're ready to put the chip in and test our circuit. So the next thing is the last resistor. Same as before, I'm going to pre-bend that. Either end goes in. Pull it through. I'm also going to put my 2 capacitors through as well. Try and do all of those at once. Okay, so I've got all three of those items sitting there. Alright, trim those off as always. And the last piece is our little oscillator, which you'll see is listed as X1. Same as everything else, the prongs go in. Put it so that the little, it says 16.000. Let's have that sitting up the right way. Just looks a bit neater. All right, flip that over. Last two solders. Last two trims. Have a good look at any solders here. I'm having a really good final look over all of my solders. Making sure I can't see any holes that I forgot to solder. Looks pretty good. All right, the last two steps for the circuit part of this project is connecting the chip into the holder and then connecting my 9-volt battery to the power connector. So here's my chip again. I'm going to make sure that the notch is lined up with the notch end of this, and before I go pressing anything in, I'm going to very, very gently just make sure I'm feeling, does it feel like it's sitting in the slots in the holder? If at all it feels wobbly or looks like something's sticking out, don't push it all the way in, just take your time, no rush. And when you're happy with it, I would use both ends of the chip and just kind of push it either side until you feel that it's gone in. And just be careful when you're pushing against these sharp prongs here. Might pay to put it on your table or workspace. All right, with the chip in place, it's time to connect the battery. So I'm going to do a bit of a clear off of my bench space. All of these little offcuts, I'm going to get rid of those, and then we'll move on to checking the circuit and then putting together the frame of the clock. Okay, so with everything now soldered to the circuit, it's time to test out the circuit. I'm going to connect a 9-volt battery, one like this, to the battery connector. Now you'll notice that one will fit in the other, so just make sure you get that round the right way before you touch them on. And hopefully what we're looking for is a bit of a display to come up here. All right, so you can see that our display is flashing 12 o'clock and the seconds LEDs are also flashing every second. So now all we need to do is set the time correctly. So let's say that it's 2:10, then I use the hours button, 1, 2, and the minutes button to adjust 2, 3, 4, 5, 6, 7, 8, 9, 10. One more. 2:10. So on camera, that's probably not showing as clearly as it will in real life. That's just the way cameras work. But from where I'm sitting, we've got ourselves a successfully running circuit. Last step now is to connect all the hardware up together so that our clock will stand on its own. Let's do that next. Okay, so there is a certain order to this that we need to make sure we do. Otherwise things will have to get undone and redone, which you can do, but it's probably better just to do it the first time. So we're going to start with the front of the clock. So we've got these two clear acrylic sheets, and I'm going to peel off the protective side of one, side, and that's going to be the side that goes against the circuit board. So I'm going to try not to touch that with my fingers because I'm going to put fingerprints all over it. So the outside will keep the plastic on so we can touch that, but the inside stays clean if we can. I'm going to put these 4 bolts with the head of the bolt sitting there like that. And I'm going to do 4 of those. 1, 2, 3, and the last one. And then these are going to line up with the holes that are already drilled in our circuit board. But I need to put these little spaces in, and that will keep the circuit up and away from our electronics. So I'm going to slide spacer in between each one. Okay, and last one. All right, now if you can get those bolts lined up with the holes on the circuit board, you're on a winner. I've got to flip it up onto its side. So I'm very carefully doing that, and what we should see hopefully is that those bolts will drop down through the circuit board. That's what we want. Awesome. Okay, now we do the same thing but on the back. So I slide those last 4 spaces on each of the bolts. Then I'm going to need to take the plastic protective sheet off the one side of the back, trying not to touch it. Probably would be better to do that before you do all of this, but it's doable. Then without touching that, so we don't get grubby fingerprint marks, we're lining up the holes again. All 4. Once you've got that, what we're going to do now is lay it down this way. Now all we need to do is get the 4 securing nuts, wind them on. They only really need to be finger tight to make this work. If you wanted to tighten it, you could, but don't over tighten it. Don't want to crack anything, especially not the circuit board. So just finger tighten up all 4 of these. Remember to go clockwise or right for tight and left for loose or anti-clockwise. Last one, wind that on. Finger tight. All right, so we've got ourselves a nice little clock that will sit there on its own. I would be tucking the battery behind it. And the reason why we haven't put the battery inside is because that makes it a little bit harder to change the battery. And it's probably the only thing that will need changing over time. So I've now got everything in there. You'll find on yours that there's already 2 holes on the hour and minutes buttons so that you can access those to change the time when you need to. All you need to do is just with a skewer or a little screwdriver or something, reach in and press those buttons. Otherwise, we've got ourselves a digital clock that stands up on its own, and you can put that anywhere you want to keep track of time so you're never late for anything. Good job, Circuit Kids. Another project done.